This video is going to be a live demo of a Maclaurin approximation. So, if you're watching this video, you have heard of a Maclaurin polynomial and that they are used to approximate certain known functions. For example, we are going to be using sin of x in this video to demonstrate the Maclaurin approximation. So, for our first equation, I typed in sin of x just so when I type out the Maclaurin polynomial, we can see how it is approximating this function. So, let's start out with a few terms in our Maclaurin polynomial for sine. As a fun fact, this approximator is an alternating series. I have added two terms in the Maclaurin polynomial for sine, and as we can see, our approximation has been able to match a certain portion of sine of x. Now, what I want to draw your attention to is this. This is what is meant by the Maclaurin series being a special case of the Taylor series where it is centered at x equals 0. If I type x equals 0, that's another equation, we can see our Maclaurin approximation will be more accurate closer to x equals 0 and less accurate farther from x equals 0. Well, what can we do to make our Maclaurin approximation of sine more accurate? Well, let's add some more terms. With this term added, we've been able to match more of the sin of x polynomial. Let's see what happens if we add a few more terms. Our Maclaurin approximator has been able to approximate the sin of x function very well. If we zoom in enough, it looks like a near perfect approximation, not exactly, but as we get farther and farther away from x equals 0, we can see that our approximation is becoming less and less accurate. Now, might I add that the Maclaurin polynomial for sin of x is an infinite series, so we can just keep adding terms and going on and on and on, and sin of x is a polynomial that has an infinite domain, so this can really keep going on forever. But right now we do have a decent amount of terms to illustrate the point that adding more terms makes the Maclaurin approximation for a polynomial more accurate. And we also got to see what it truly means for a polynomial to be centered at x equals 0. Which is that it's more accurate towards the center and less accurate farther from the center. That's all for this video. Thank you for watching and good luck studying!